All right, welcome back, everyone. Today we're going to talk about parallel and perpendicular lines. Okay, so in this lesson we're going to learn how to determine if two lines are parallel, perpendicular, or neither, how to write the equations of horizontal and vertical lines, and how to write the equations of parallel and perpendicular lines. So parallel lines are two lines that, when they're graphed, will never cross each other. This is because two parallel lines have the same slope. Parallel lines have the same slope. You look at these two green lines here on the graph, you can see that those two lines have the same slope. They both rise to and go to the right one. So to determine if two lines are parallel, you just have to check to see if their slopes are equal. If the two slopes are equal, then the lines will be parallel. Remember that sometimes you have to write the equations in slope-intercept form before you compare the slopes, because that way it's easier to pick out the slope in the equation. Perpendicular lines are two lines that cross at a 90-degree angle. Two lines are perpendicular if their slopes are opposite reciprocals. What that means is just to take the fraction, flip it over, and change the sign. So for example, if the slope of a line is negative 2/3, and that's what we're going to see here, this is this line, it goes down 2 and to the right 3. So that slope is negative 2/3. Then the slope of a line perpendicular to it will be positive 3/2. And we can see that from this line here. Rises 3 and goes to the right 2. Slope is positive 3/2. So these two lines are perpendicular. They cross at a 90-degree angle. Once again, to determine if lines are perpendicular, we just have to compare the slopes. And it's always important to remember to write the equations in slope-intercept form first. So we want to determine if these given lines are parallel, perpendicular, or neither. Our two equations, y equals negative 3x minus 2, and y equals negative 3x plus 5. Well, these are already in slope-intercept form, and so we can look at the equations and tell that the slope of the first line is negative 3, the coefficient of x, and the slope of the second line is negative 3. The slopes are equal, so these lines are parallel. We go to the next example. We have 3x plus 5y is equal to 12. And negative 5x plus 2y is equal to 17. We need to compare the slopes of these two lines, so we first need to write them in slope-intercept form. On the first equation, we're going to subtract 3x from both sides. And we'll get 5y is equal to negative 3x plus 12. Divide everything by 5. And we get y equals negative 3/5 x plus 12 over 5. And so the slope of our first line is negative 3/5. If we do the same thing for the second line, this time we're going to add 5x to both sides. We get 2y is equal to 5x plus 17. Divide by 2. And y equals 5/2 x plus 17 over 2. So our slope here is 5/2. So notice first that the slopes are not equal, so these lines are not parallel. And the slopes are not opposite reciprocals. If we flip the first slope over and change the sign, well, we get positive 5/3. So they're not parallel and they're not perpendicular. And so these two are neither. Okay, so let's try another example. We're just going to try this again. We want to determine if these two lines are parallel, perpendicular, or neither. We've got y equals 3/4 x minus 9. And y equals negative 4/3 x plus 3. In our first line, our slope is positive 3/4. In the second line, the slope is negative 4/3. Obviously, these two are not the same. However, if we take the first slope, m1, and we flip it over and we change the sign, you will get m2. So these two are perpendicular. Try another, and this time we need to solve it. Two x plus 7y is equal to 19. We'll subtract 2x from both sides. We get 7y is equal to negative 2x plus 19. Divide by 7. And y equals negative 2/7 x plus 19 over 7. We do the same thing with the second equation. Negative 7x plus 2y is equal to 11. We're now going to add 7x to both sides. We get 2y is equal to 7x plus 11. Divide by 2. And y equals positive 7/2 x plus 11 over 2. So now we need to compare the slopes. The slope of the first line is negative 2/7. The slope of the second line is positive 7/2. These two are opposite reciprocals, and so the lines are perpendicular. Not all lines have to be parallel or perpendicular. We've seen one example already where they were neither. If two lines do not have slopes that are the same or they're not opposite reciprocals, then they're not going to be parallel or perpendicular. And once again, to determine this, just compare the slopes. Now we're going to talk a little bit about horizontal and vertical lines. The equation of a horizontal line is written as y equals b, where b is the y-coordinate of the y-intercept. We've talked a bit in previous lessons about horizontal and vertical lines. Given a point on the line, the equation is simply y equals the y-coordinate. Same works for a vertical line, except we're going to talk about x. The equation of a vertical line is written as x equals a, where a is the x-coordinate of the x-intercept. And given some point on the line, the equation is simply x equals whatever the x-coordinate is. So let's try this. Here we want to write the equations of the horizontal and vertical lines that pass through the given point negative 5 and 3. So first let's plot our point negative 5 and 3. We want the equation of a horizontal line that would go through that point. And so a horizontal line is y equals some number. And it's going to be y equals whatever the y-intercept is. And here we see that it crosses at y equals 3. And so the equation for the horizontal line is just y equals 3. If you notice, it's just y equals the y-coordinate of the given point. Now, if we want to find the vertical line that goes through the same point, the equation of a vertical line is going to be x equals, and we just want to figure out what x equals when we cross the x-axis. Well, when we cross the x-axis, crosses at negative 5. And so the equation of the vertical line is just x equals negative 5. There's no work to be done on these problems. You just have to recognize the equations for the horizontal and vertical lines. Now, horizontal and vertical lines can be parallel and perpendicular as well. Horizontal lines are always parallel to other horizontal lines. Vertical lines are always parallel to other vertical lines. Remember, horizontal lines have a slope of 0. So if you have two lines that have the same slope, if they're both 0, then they would be parallel. Vertical lines would be very similar to them. However, if you have one horizontal line and one vertical line, they are always perpendicular. They'll always cross at a 90-degree angle. So to write equations of lines perpendicular and parallel to horizontal and vertical lines, just remember these rules. Okay? We're going to practice this. So we want to write the equations of the lines parallel and perpendicular to the given line and crossing through the given point. Well, the given line is x equals -1. This is a vertical line. So if we want to write the line that's going to be parallel, then we need another vertical line. Our given point, again, is -5 and 3. And so we want the vertical line that goes through this point. Well, as we saw in the last example, the vertical line that goes through that point, x equals -5. That line is going to be parallel to the given line, x equals -1. Now to find the line that's perpendicular, horizontal lines are always perpendicular to vertical lines. So we need the horizontal line that goes through the given point. And so if we draw a horizontal line through the given point, we'll see the line is y equals 3. Finally, we need to be able to write the equations of parallel and perpendicular lines for linear functions that aren't just horizontal or vertical lines. This is very similar to writing the equations of other lines. If you watch the video from the previous section, this will help in this section. We're going to be using the same steps. To find the equation of a line parallel and perpendicular to a given line, we first need to find the given slope. Once we have the given slope, if we want the parallel line, we're just going to use the same slope. And if we want the perpendicular line, we're going to use the opposite reciprocal. We're just going to flip the fraction and change the sign. Once we have the slope that we're going to use, we'll use the given point to calculate b, or the y-intercept of the new line. So let's try this. We're going to write the equation of the line parallel to the given line and crossing through the given point. So we want it to be parallel to y equals -3x plus 5. That's our given line. The slope of our given line is the coefficient of x, so the slope of our given line is just -3. If we want to find the equation of the line parallel, we're just going to use the same slope. Parallel lines have the same slope. And so the slope we're going to use is going to be -3. So now that we have the given slope and the parallel slope, we're going to use the given point to determine the equation of the line. So our given point is -2 and 1. And so we have the slope and a point. So just like before, we're going to use y equals mx plus b. And here we're going to say y is 1. X is -2. And m is negative 3. If we then solve for b, we get 1 equals negative 3 times negative 2 is positive 6, plus b, subtract 6 from both sides, and we get b equals negative 5. And so the equation of the parallel line, y equals our slope, negative 3x, plus our y-intercept, which is negative 5. Notice that the answer has the same slope as the given equation, but a different y-intercept. Now we want to find the equation of the line perpendicular to this given line. Well, first of all, what we're given is 3x minus 2y is equal to 13. We're going to want to calculate the slope of the given line first. So subtract 3x from both sides. We get negative 2y equals negative 3x plus 13. Divide by negative 2. And we get y equals positive 3 halves x minus 13 over 2. And so our given slope is positive 3 halves. We want the slope of a line perpendicular to this, so we're going to need to find the opposite reciprocal. So our perpendicular slope, we're going to flip the fraction and change the sign. So 3 halves becomes 2/3, and it's negative. And now we have our given point, negative 5 and 4. In fact, we're going to move to a new slide. We've got the slope of our perpendicular line, which is negative 2/3, and the point, which was negative 5 and 4. And we're going to say y equals mx plus b. And we want to solve for b. We want to solve for b. So we're going to plug everything else in. Y becomes positive 4. M is negative 2/3. X is negative 5 plus b. So that's 4 is equal to, this is negative 5 over 1. Negative 2/3 times negative 5 over 1 is going to be positive 10 over 3 plus b. We're then going to subtract 10 over 3 from both sides. Remember that when you subtract fractions, you need to find a common denominator. So 4 is the same thing as 12 over 3. 12 divided by 3 is 4. So 12/3 minus 10/3 is going to give us 2/3. Now we're not quite finished. We need to write the equation, which is going to be y equals our new slope, negative 2/3, x plus b, so plus 2/3. So at the end of this lesson, you should be able to determine if lines are parallel, perpendicular, or neither. You should be able to write the equations of horizontal and vertical lines. And you should be able to write the equations of lines parallel and perpendicular to given lines, including horizontal and vertical lines.